What up, nerds? This is Bryson. You can call me Bammed, and this is CTF and Cigars by Bam CTF, where I smoke a cigar and talk about CTF things. So this week, I'm gonna start off with it's a Drew Estate Undercrown, the Maduro version. You can see the little Maduro label here at the bottom. So this is, let's see. It's got a Mexican Sendres Maduro wrapper. It's very finely wrapped. Smells great. It's the filler. It's a Connecticut River Valley stalk cut, cured, sun-grown Habano binder, and a mixture of hand-picked Brazilian Mata Fina and Nicaraguan Habano long fillers. So there's a lot of stuff in here. It's a very much heavier body, much more bold cigar than the last few that I've had over the past couple of weeks. So it's got a bit of a punch to it. It's not too bold, but it's definitely more on the bold and the full body side than the Olivas that I've had the past couple of weeks. So let me get this lit. So a couple notes about this one. So I've had a couple of these already this week. Took a few notes, looked up what other people had to say about it, and the main thing you get from this. So it's a little sweet, and very woodsy. There's definitely like kind of an oaky flavor to it. A bit of vanilla. And that Maduro, so the Maduro is the darker wrapper that you'll see in some cigars. So you see the lighter ones, which are the Connecticut, and the darker ones are the Maduro. The Maduro gives you that more richer, that dark coffee and chocolate kind of flavor to that. And you definitely get some of that, a little bit of black pepper, but yeah, definitely that oaky, woodsy flavor is coming out pretty strong on this one. So this is a nice smoke. I'm going to enjoy this. And while we're doing that, I'm going to bring on a guest. So this week, I've got Jason. Jason, say hi. So
Hello.
Jason, why don't you tell us just whatever you want to share about yourself? I don't want to dox you and say too
Okay.
much myself, so I'll leave that up to you.
Name's Jason Slagle. I am a 20 plus year Linux Unix nerd. Uh, don't know what else to say. Work for a company called CNWR here in Toledo, Ohio. We're a managed service provider that does some security stuff, some Linux Unix consulting on the side, and I like to do CTFs.
Awesome. Yeah, thanks for joining us. So I've mentioned this before. So I work for a company called Perch Security, and one of the things that they've let me do and has been a big bonus for the company, has been a lot of fun for me, is they've let me put together several CTFs this year. We actually just had our 5th CTF sponsored by Perch this week for 2020. So there's been several. It's we're in October, so that's basically every other month. Spend a few weeks playing this a CTF and then running it. And Jason has been kind of the all-star on a couple that we've done. I think he got first place multiple times, and definitely has done a lot of good work with some of the Crackmes that we've done. So I've put together some Crackmes, and to be perfectly honest, I didn't write all these from scratch. I did some Googling, found some other people's GitHubs where they had written some Crackmes, copied the code, and then made some changes, tried to make some a little more difficult, tried to maybe add some tricks in compiling and that sort of thing as well, or add some extra fields that were required to make it a little more difficult. But anyway, so the Crackmes that we'd used in the CTFs earlier this year, I put them up on my GitHub, and if you have gone to my site, it's bamctf.com, so it's bamctf.com, and then click on you can just type cat crackmes.txt. So if you've been on the site, you notice that it's actually got a Linux command line you can use to interact with it. But there's also menus on the left-hand side if you want to access those, and just click on Crackmes, and that will take you to the Crackmes that we're going to be looking at today. So hopefully I found the right ones. Wasn't terribly organized in keeping track of what I had between the CTFs. For the most part, once I finish it, I'm like, I'm done, and then just kind of moved on. But I'm pretty sure I found the right files, and I guess we'll find out later. Before we get started, we'll go ahead and have a drink. So, Jason, what are you drinking this morning?
We'll start with the High West or Double Rye. It's pretty good. I like it. It's become one of my daily drinkers since somebody recommended it to me.
Interestingly enough, somebody recommended that to me yesterday too. It wasn't Wes, was it? Did he recommend it to you?
It was
Same
definitely
thing.
West.
He recommended it to me yesterday, so I picked up a bottle. I think I left mine inside. I'm drinking the. Let's see. I've got it with me here. It's the Four Roses single barrel. It's pretty good too. So that's what I'm going to start with today. So cheers.
Here's Yeah, I've definitely got some Lagavulin 16 sitting here
Oh,
too, in
nice.
case things get hard.
Yeah, I've been trying to
So,
get my hand on the Lagavulin, the Nick Offerman edition. Have you seen that?
yeah. That's So my wife got me the 16 because that's what he
Yeah.
actually drinks in the show. It's very peaty. Took a little bit of getting used to, but actually, it's kind of like developed that taste buds for me. So I'm kind of digging it now.
I like Lagavulin. I drink a lot of Lafroig and Ardbeg, which are also very peaty. They're from that same Islay region of Scotland. Islay or Islay. I don't know how you're supposed to say that. I'm not Scottish. Okay, so let's take a look at some Crackmes. All right, so you should be seeing Jason's screen now. Any chance you could increase your font just a bit, just to make it easier to see?
There we go. Cool.
Yeah,
Got it now. Is that better?
That should show up. Nice.
Cool. Yeah, so I'm a weird duck when it comes to that. I do these things across 3 different machines, running 3 different Kali instances, and much like you're not good at taking notes of what you've produced, I'm really bad at taking notes of what I've solved. So we're gonna have some fun here, resolving some of these things. So cool. Let's take a look. I figure it makes sense to start with the V CyberCon ones, right? Because they were first. So the first one we got here is this V CyberCon. Do you have the answer still? Tell me if I'm correct.
No. We'll
Okay.
see what happens.
I think I do. We're good here. Okay, so we've got a Crackman here. We're going to go ahead and run it. It's going to tell me I'm not correct. So this is clearly a Linux binary, right? We can run a vCyberCon on it, or run a file on it. It's going to tell me it's a ELF, probably 64-bit ELF binary. Yep, it is. So we run our answer here. We see it's not correct, so it's like, okay, well, now what do we do? My first go-to tool when I'm doing this is first I'll run strings on it, right? Because if you're extraordinarily lazy when you build these things, then it'll pop out in strings. It's not gonna. I can tell you that offhand, right? But we do have keep it purchased. That's actually probably relevant here at some point or another. So the next thing I will do is I will pop it open in Ghidra. I've used IDA. I use Hopper. I've used Ghidra. IDA is my favorite, but I don't have like $4,000 lying around to actually buy it. So I've fallen back to using Ghidra here a lot now. We'll go ahead and we'll let it analyze. It goes pretty quick, unlike the binaries that we'll take care of later. And we can see here, looking at the C code, the first thing I tend to do is I'll edit the function signature and make it not stupid. I don't know why this can't figure out that this should be an in and this should be a char star, but doing a little bit of C knowledge here definitely helps. Yeah, I mean, C was my first big boy language. So immediately we get something more useful there. We'll just rename that to be I because clearly that's an index variable. And yeah, so this is a lot easier to read now. So we can see that essentially we've got keep it perchy and we're subtracting 2. So I'm going to go out on a limb and say that it's going to be what, J? All right, so keep it perchy. We'll do. Oh, now I'm gonna have to remember how my alphabet works.
So if you want to use was it crypty.com, they've got a quick you could just paste that in there and apply a Caesar cipher. I think that's where we're going with this.
Yeah. It's not Caesar, but
Just a substitution cipher
not
or
like
a shift.
yeah. It's basically like
Yeah, yeah,
subtract.
or Cyber Chef should be able to do it too.
Yeah, Cyber Chef is my tool of choice
Yeah, I
for
use
doing
Cyber
things
Chef
like this.
daily at work,
Uh,
all the time.
just got to find the right string add. We don't really want to. No, okay. Well, we're gonna. Let me look at. Let me Google real quick.
If all else fails, don't forget to RTFM, or these days, most of the time, that really just means
Yeah.
Google it.
Yes, it does. Yeah, I can't really find a way to do that. So we're not going to do that. I'm going
All
to go
right.
back to doing what I was doing before because that will work. Just yeah. Uh, this is just proof that I'm not very good at the alphabet. Uh, so we've got and C T A F W. Boom. we can totally
All
do this by
right.
hand.
Nice.
Okay, so that one was super easy, right? Like that one was ridiculously easy, right? So as you would expect, this was intended to be a relatively new uh, new CTF player challenge, right? So again, right, like looking at the C code here, right? Like basically we have a loop here. Can I make this big guy bigger? I bet you I can if I try. Well, for sure we can do this, right? We'll just okay. What is the control should be? There you go. Cool. So now you can see
Yeah,
it.
that's good and clear.
Oh, okay. So yeah, that's a easier way to see it. So we've got this I var. I have no. That's just return. We've got an index I. If we don't have an argument, then we're gonna say we need one argument. We're running a loop here. One of the things Ghidra does that annoys me. This is probably a for loop in the code, I'd guess, but it's turning it into a while loop because I can't tell. But it's not the end of the world. All right. So we're basically walking over this while we're not at the end of the string, either string. We compare each character in the string. Basically, we add -2, so we're subtracting 2 from it. As soon as we get one wrong, we return and say it's not correct. This actually has some nice things in it from a Crackme perspective. One of the things that it has is I would not expect at any point to find the entire string in memory in this case, right? Because it's basically we're bailing
Yeah.
as soon as you get one wrong. Uh, uh, the second thing, well, I mean, I guess that's the biggest thing that I wanted to go through. It also doesn't have the answer, right, as a string, so we're not going to
Right.
be able to pop it out with strings. So we'll move on from that one. So then we got another one. Also a Linux binary. Also without, so that's kind of interesting. We're going to go ahead and we're going to open that one. I looked at this one several days ago, so we will. Yeah, we do here. This one. Okay. So same sort of thing. I'm going to go through and I'm going to fix this to not be silly. That's it. That was cool. All right, we'll change our function signature here so that this gets less gross down here. Here of note, we've got some basically some sort of string. We've got this variable here that, as best as I can tell, it isn't actually used anywhere in the code. And then we've got, I bet you just use code. I bet you it's just one more fight. And then we've got, yeah, for sure it is. And then we've got this string here. We've got a 5 down here, right? So then if we go down here and we look at this, we've got this function here called check password. If check password passes, if check password passes, then we're good. If not, then we bail. This one, I'm going to suspect that if I break on printf and GDB, I'm going to be able to pop the answer out. Right, just because we're passing the string in here, right, and we're returning, and we're looking at the return value here. So if I break on this printf and go up and look at the stack, I bet you that answer's on the stack. So we're gonna go ahead and give that a try. I can't promise that that's gonna work out that way. Okay, I use an extension for GDB called PETA. PETA. I don't know how to say it. It makes life a lot easier. I'm gonna feed it keep it perchy because I just go there immediately. And we're gonna break on printf. Run.
All right.
Probably gonna tell me I'm wrong. So if you see here, see all this cool stuff PETA is doing? Right, when we hit our breakpoint, we got a whole bunch of useful information here. That's interesting. Right, so that's clearly what that string means. Right, so let's do strings stack with the minimum length of 2. Okay, let's try it somewhere else then. Okay, we're gonna come back here. We're gonna try one more time before I go doing it the hard way. And by doing it the hard way, I'm just gonna make the program tell me what the answer is. No, we're not gonna get the answer on there looking at this function. We'll go ahead and edit the function signature of this guy. This is also going to return an int. It's taking 3 pointers. I think the third one's actually a the length. Let me take a look over here. Back in main. No, they're all. Okay, so we're going to cheat on this one. I'm going to do the same thing I did before. Cool. So now we've got some interesting stuff here. Those are just char stars. They're not double pointers. What am I doing? They're just pointers. They're not double pointers. There we go. That cleans that up a lot. You can usually tell if you've got the function signature right because the code gets a lot less gross. Right. So now we can see. We can notably see what this is doing. This is taking the third parameter. So the first parameter is what we sent in, right? So that can be renamed to be input. Right. The second one is key. Right. We'll call that key. And the third one is offset. Right. So basically, we're adding the offset and the key together and then comparing them, right? So if we go back over to our main function here, we can actually see this is our key, which is that vCybercon text, and here's our offset. So we're just going to add like 6, 2, 9, 5, 1, right? So it's basically the same challenge as the first one, except instead of adding 2 all the time, now we vary what we add, right? So because I'm extraordinarily lazy, we're just going to copy this out. I'm going to assume that we need both string.h and the standard lib.h. I'm not sure, but
Probably.
yeah. Won't hurt. Can always have too many. And then the other thing we're going to do, we're going to grab our function here, our check conf or check password function. It's right here. We also need that. All right. Cool. Let's see. We'll just make a output, and we'll just do a output local C because I didn't rename that one equals offset local C plus key local C. All right. On here before we return 1, we're gonna printf.
So the main thing to get from this, if you haven't picked up on it, is you got to learn C.
Yeah. Yes. Yes. I do this a lot. And I mean, I don't know. I think those are ints. We'll call them ints. I think on 64-bit, so my int should be 64-bit on this box. Yeah, I mean, I don't know how to or what other way to give it that. I saw things using C a ton.
Yeah, I mean, to be fair, I pretty much wrote them all in C because that was what I was most comfortable with.
Yeah.
I know.
Why are we not?
I think Taylor is watching us, and I know he tried to do one in Python, but that was just too easy because you could just even if. Yeah, it was just too easy to see what was going on when doing it in Python. But at least with C, I could, you compile it so you don't just get the answer. You got to at least disassemble it. And then, some of the later ones, I really tried to screw with you using the Movefuscator.
Yeah.
We'll get to that.
Okay, so this one we ended up with some non-printable characters in there. That doesn't seem right. Can you remember if the answer to this one required a hash or did it require the actual string?
I think it was that. No, it was a string.
Okay.
So.
I mean, that seems like the beginning of it, right? Like.
Where
did I mess up here? Okay, that's fine. Oh, those aren't ints. They're long. That's why we only got 4 characters. Two, 4, 6, 8. Okay. We can do the last one by hand. So the last one is going to be, last character there is going to be 6E plus 5.
That's exactly what I would do. Man, ASCII. Yeah,
Really?
yeah. I'm always telling people that. Man, ASCII.
So it's N. It's 5 characters after N. So N plus 5 is going to be what, 7 3. So the last character should be. It's either going to be either a semicolon or a colon. So. It's probably a semicolon because that's the evil way to do it. Nope, it's going to be colon. No, I'm just going to count. Okay, hex 60. 2, 3, 4, 5. No, it's an S. What was I doing? Oh, I ended up on the left
Yeah, I
side.
think you were looking at maybe the octal or the decimal.
It's an S. I ended up wrong in the
There we
table.
go.
There we
Yep.
go. All right, so I mean, I probably approached that in a relatively non-traditional way. It's what I do. But I mean, got through it, right? Like, in the end, I could have simplified that C program a lot. We'll go back and look at it. So here's what I essentially did. So I took the whole program, right? And the reason this ended is because GCC is going to be nice and basically null terminate that. It's not going to pack that long in directly after. There's going to be a null byte in the middle, right? And that's why it ended there. If I could have used a different data type there and it would have worked fine. But basically what I did is in the password checking function, and actually when I did this originally, I used this exact same methodology and had that exact same bug where it ended one character too early. Now that I recall, I took this function here and instead of making it immediately return when I got it wrong, I just added an output variable and just made it walk through the whole loop anyways and just put the answer in
Yep.
there. And then at the end, I just made it spit the answer out.
Yeah.
Right. Like, if you can make the source code of the program give you the answer instead of checking the answer, then man, you win.
Oh yeah, definitely.
Okay.
Yeah, I don't consider that cheating at all. I think that's a pretty valid technique.
Now the Windows one. So full disclosure, I didn't solve the Windows one when we did this. There is me and a guy that works for me named Damon on my team, and Damon is actually the one that solved the Windows one. So when we've done these challenges in the past, typically I delegate to him, and it's like, okay, I know you know how to do this one, this one, this one, and this one. So go to these while I work on this hard one. Or when we were at the day 2, when we were at the what was the second one called? It wasn't vCyberConf.
It was the Cyber Trifecta.
Yeah, CTF.
Yeah.
Okay. When we did that one, I would put him off like, I need this piece of this one solved, and he would go solve it while I was working on something else. And that was the CTF one was actually really fun.
Awesome.
I don't know, when we get to that, we can talk about that a little bit. Going through basically and having to hack into that box, especially once we ended up having to get into that web server, we spent half the day really demoralized, thinking that we were screwed, because what we didn't realize is that the people that had more challenges than us, they had found an extra web directory that we had not found. So we actually didn't solve those challenges that a bunch of people had, and so we ended up on the box. But as it turns out, we were the only ones on the first box. Like, we were the only ones that had gotten into it, and so by the time we hacked into the second box, things just immediately popped. So that was fun. So cool. So what we got here, I actually started going through this one the other day. Man, I wish I could make this bigger. There's got to be a way. Take a second to try to do that.
Can't just like Control Plus or something.
Yeah, I tried that. Yeah. Let me see. I'll Google it real quick.
So we got a few people in chat. Anybody in there know how to increase the font in Ghidra?
No, there's actually a GitHub issue that's called font size is unchangeable.
Okay. All right. Well.
Oh, hold on. We found it. I found it. Somebody closed it. It's apparently under Edit Tool Options Listing Display. Look at that.
Oh wow. There we go.
We're gonna roll with Hack here because Hack is my. Everyone has their favorite pet font. I suspect mine is definitely Hack. Did it get bigger? Oh, that got bigger. Oh, screen element. We want the. No,
So this is proof we're actually doing this live. If this was pre-recorded, we'd take the time to edit this stuff out.
We definitely would do that. Yeah, that's fine. Okay, so here we have an interesting one. I don't know how to run this, so I'm just gonna walk through how I would solve it. Like I'm on a Windows box here, so I could run it, I guess. So we'll see here. If I get it real quick, we'll solve it. So again, I didn't actually solve this one when we did it. So let's go ahead and rename some variables here. I've determined this is probably some sort of key, so I've already renamed it to key. That's a long local 68. Let's see what that does. So we've got a rename that to be key length, because that's clearly what that is. No, that's yeah, okay, that's RV1. Yep. I don't know why we have two of them. We're gonna rename that one to be actual key length.
There were occasionally I threw in some unused variables or functions that did nothing. I don't remember doing that on this one, but definitely on the Cyber Trifecta there was a lot of junk code in at least one of those.
Oh yeah, yeah. There was, and I think you tried to be clever on that one, thinking you were gonna trip me up, and
but it ended up just being in memory after all. Yeah.
Yeah, it didn't stop me at all. Okay, so we've got all these variables here. I mean, we can see this. So here's what's actually going on, right? So the gut of this is so this is Windows. So I have a feeling that internally all of the characters are Unicode. Right, so that's why for every one of these characters we're moving 4, right? And that's just obnoxious. Like it makes the life so much harder than it actually needs to be. But essentially, it looks like what we're doing here is we are exclusive ORing, right? That's the bitwise. Yeah, that's a bitwise exclusive OR. Oh, is that power or exclusive OR? God.
No, it should be the XOR.
Okay, that's what I thought. I don't know why my brain is like questioning that. Okay, so that's exclusive ORing what we sent in with the key, and then we basically put that into a variable, and then we go ahead and we call the z check pass. So let's see if we get lucky here. It might just be the case that we go into the z check pass and we find the password in here somewhere, like right here. Right. So basically what I would expect is that the key, what you pass in exclusive ORed with this stuff in main here.
Yeah, that sounds right.
Has to equal this string right here, right? And like looking at it, that's definitely that's exactly what we got going on here, right? So I'm not gonna run through and solve that like I could, or in this case, I would actually expect us to be able to find somewhere in memory where this is probably pretty close. So, but I hate WinDebug, and unless you force me to, I'm gonna steadfastly refuse to stumble through it and embarrass myself. So we're gonna move on if that's okay
Yeah,
with
that's
you.
fine. So for those of you who missed it, there basically was, it takes your input, and then there's a key that is in the code, and that just does an XOR byte by byte from your input with the key, and then if you're and then that it checks that to see if you get the right output. So it's just using XOR. If you don't know what XOR is, Google it. It's just another bitwise operation, such as, you know, and, or, not. XOR is another one. It's a very simple way to do encryption, I suppose. You'll see that used in, like, malware tends to use that a lot to just hide something. You XOR against a common byte, and that way the string isn't there, it's not visible, but it's a very simple function to reverse.
Yeah, you think that a lot of these skills so actually that was just something that came up in the Hackett talk I did. You think these CTF skills you learn are like useless, but when you start talking about things like DNS tunneling, they're way more useful than you actually probably realize they are, right? Because the people are trying to hide their shit using stupid tricks, and stupid tricks are stupid. Cool, moving on. Let's see. Let's do a fun one. Mostly because I want to drink this Lagavulin. Let's do this one. If that's okay with you, I'm going to jump ahead to the Cyber Trifecta Crack Me
Yeah,
2. Is
go
that good
for
with
it.
you? Okay, cool. So again, we've got this binary that they sent us. This is the one here where person attempted to be a little bit tricky and thought I would spend longer on this than I actually did. So we have
After the first
a binary here
CTF, I
again.
wrote all of these with Jason in mind.
I mean, it was fun. So we're gonna go ahead and we're gonna open it here inside of a Ghidra. Although I don't even know if I opened this one in Ghidra when I did it. I may have just gone straight into GDB with it. So analyze it. Oh, it's this one. It doesn't have a main.
That would be too easy.
I remember this one. Yeah, that's fine. We don't actually need to use main. Can do libc start. Oh yeah. Okay, this one's obfuscated that way. Yeah, it's one of these. We'll find it. You know what we're gonna do? We're gonna go show references to, because we know you call. I know you call ptrace in this one. There we go. There's our function. We found it. It's not called main. We got it. Okay, cool. So we've got this program here, right? And it's doing a number of things here. This one is a lot more obfuscated than any of the previous ones we've looked at. It's got some ands in here. It's got some like knots. It's got a bunch of binary math in here. It's doing all sorts of this crazy crap that I looked at this and I'm like, are you flipping kidding me? So the first thing we're going to do is we're going to try to get it running in GDB.
So if I remember correctly, I had two functions in there. One of them was called success, and then the other one I think was just named some random characters. And some of those other operations you were looking at, they would call success, but not when there was actually success. They were just specifically put in there as wild, as rabbit holes to go down. And the actual success criteria called some function with some random characters.
That's amazing. Okay, so you're being sneaky,
and
right?
I'm pretty sure
shit,
the success function, the fake one, it actually loaded like this is the correct string into memory, and then it printed something else. So it would load it would load into memory. This is correct to make it look as much as possible that it was correct,
Oh,
and then it would unload it and like print an empty byte.
that's
So tried to throw people off a
awesome.
little bit there.
So we've got anti-debug in this, right? So as soon as we get anti-debug, then I'm going to assume somewhere we're calling ptrace. You can see it right here. We're calling ptrace. So we're going to super cheat here. What's the Kali hex editor called?
Yeah. So
Probably
for
hex
those not familiar, whenever you load something in a debugger, it calls ptrace, and so what I'm doing is just checking to see if ptrace is called, and if it is, then it just exits the program.
Yeah.
So without, if you just load it in GDB, you'll get what happened here. It's just going to crash. And again,
We're going to load it into hex editor. I think there's a command I have to be able to use to no. Okay. I thought there was a command I had to be able to use to edit that. But we're gonna go find our call to ptrace right here. Okay, so it's at 10179B. All right, looks that way.
yeah.
Yep, 179B. Okay. Is that right there? Oops. Back over here. What's our actual hex code to call ptrace here? So right here. E830F9FF, right? So that's the actual Intel opcodes to do a syscall to call ptrace, right? So we don't want to do that. So E83059 or F9FF. Go back over here. E830F9FF.
If
Nope.
you guys go back and watch an episode from a couple weeks ago, where I had Ross on and we were looking at the stuff from B-Sides Houston, I actually did something similar to this, and I went through and gave you a reference on where you can find opcodes and what they mean and how you can edit them. I think we took we had a program that had a jump if equal or jump if zero, and we just changed it to a straight jump to sort of rewrite the function.
Okay.
And I did that in a hex editor and just changed the opcode.
So my Intel assembly goes back to cracking BBS DOS games. And that's exactly what we would do. I would find the jump zero that went to the registration check and just change it to a jump not zero. Then any bad key would work. Okay, so we're gonna go ahead and run that. Or I edit it. So I changed. So for your information, what I did is I took this here, right? So I took the bytes here for the ptrace, right, which were the E830F9FF, and I changed them to be 9090909090, right? So 90 on Intel, I believe it's like move EAX. It ends up being like a no op, right? So it does nothing. So now instead of calling ptrace, we're just gonna not call ptrace. So now we can run it. Oh, now this thing's stupid because it's telling me I need one argument. Clearly, one argument's not enough. He's taunting me.
Yes,
So
that was another thing I lied about the how many arguments it needed.
No, it's complaining that there's no such file or directory. So it's actually one of these things is looking for a file. Pull it back into GDB. Okay, so now we've at least got it to run. It's telling us access denied. Okay, well, come back over here. Look at our code. Our code here prints access denied somehow. So what I'm curious about is how it's printing access denied. It's irrelevant. It's doing it one of two ways. It's doing most likely puts or printf. So let's try puts. We're gonna break on puts. Yeah, so we broke. If we continue, it's gonna print access is denied. So that's where we want to be, right? So now we're in the basically it's telling us that we're wrong. Well, now what do we do? Well, we've got this weird Intel genuine string in memory. I don't know what the hell that is. I do now after having seen the source code after you told us what was going on. But I'm just gonna go out on a limb and say, what do we got on the stack with the length of 2? Boom. Right there's our answer. So I actually, when I solved this the first time, I went through, as you can see here, it's actually reversed the "this is crazy" string I made here, right? And we've got this string here. So I believe the answer is actually this string reversed.
Right. So yeah, if you put that into a file, reversed.
Yeah, by itself with no new line.
Yeah, that's an important one.
Yeah. But then the problem is that I actually have never made this program successfully run. So it's got this check here where it's checking. Basically, it's this function here. I was just at it. It's this function here. It's looking at our CPU info and calling a bunch of syscalls to figure out what CPU we have, and then it's doing some sort of check against like a broken copy of the word Intel genuine. I guess I could probably patch the binary to fix it so it actually says Intel genuine because I am on an Intel CPU.
Yeah, so if you check your CPU ID, it's pulling out the processor family. So that's one of the fields. I think you can just run CPU ID on the command line. It'll give you the family name and all that.
No.
Or cat/proc/CPU. CPU info. There you go.
It's looking at the vendor ID.
Yeah, the vendor ID. That's the one. So yeah, so to get it to run, you would need that string reversed, and then genuine Intel would be the second string that you pass it.
Oh, okay. Oh, let's see. What was that string reverse? It's right here.
Yeah, once again, CyberChef makes some of this really easy.
Yep. But then you run into the other problem, and I don't know if you run into this problem. Even if I don't put a new line here, it tries to be helpful. It gladly adds that new line.
Yeah, you have to go back and take out that new line at the end. Yeah. So 0A is the hex for new line.
Yeah. I think this will be. No, I gotta do -B. Okay. That's what it was. I knew there was a way where I couldn't like edit these files in a certain way, so I got to Control-D, I think, here, and that should go away then. There we go. Boom.
There we go. Yep.
That's the first time I've ever successfully run that. I had determined that string solved it based on like getting to the success category, but I was never able to actually get the thing to run, so I just SHA-5'd it and submitted it, and it took it.
Yeah. So the actual flag in this case was the SHA-256 of the file.
Cool. Where do we want to go from here? We good, or do you want me to poke at one of the Mufuscator ones?
Let's take a look at Mufuscator if you've got time.
Yeah, I do. I do.
So this is one where I tried
Yeah.
to throw you off
Here.
with how I compiled it. So there's a compiler
Yeah.
a few years ago. I think it was at DEF CON. I saw someone who did a presentation on basically how to to fuck with people who are trying to disassemble your code. And there's this
Yeah.
compiler that was written called Movefuscator, and essentially the so it how, depending on how much you know about assembly, there's different functions you can call, and one of them is move, which just moves a bit of some one piece of memory from into, or moves data from or into a certain location of memory. And the way that machine code works, you can actually write everything only using move, and that's what Movefuscator does. So when it
Kinda.
compiles it and you disassemble it, everything just comes down to move this bit of memory from here to there, move this from here to there. And so if you just actually just disassemble it and look at the raw assembly, everything is just move. So that's it's
Yeah. What I'm
yeah,
doing. We're gonna go there just because it's worth
yeah.
seeing, right? Like this is insane. I saw this and I was like, "What in the?" And then it like super screws with you because if you're on strings on it, it's like, yeah, it just messes with
Yeah.
you. Look at this. It's insane. Uh, so yeah, I'm pretty sure this tool was made to make CTF people
That
cry.
was basically the
I'm
point,
pretty
yeah.
sure. And so somebody's written now a tool that we'll look at here a second. So full disclosure here, I used the same approach to this that I used for the previous one, which was when I solved the final, I managed to run the program long enough to actually find the answer in memory. And because I don't think this one was super complicated, the code here for it wasn't super complicated. So yeah, essentially I ran it and got it into memory. I did not demufuscate this one because I could not get demufuscated to run. So somebody's created a tool that in theory it can't completely like undo it back to source code, but it can basically give you the calling path. That's going to take a few. So let's take a look at what that looks like. So we're going to run it. I don't even know what this takes.
Yeah, this one also takes a file, I believe.
Yeah. So it's just access denied. So the problem is, right? So I'll run it in GDB. So you run into a couple of immediate things. It immediately segvies. And you're like, well, what the hell is going on here? Like,
Yeah.
I don't understand why this thing is segvying. Well, then you look at how Mufuscator actually works, and it Mufuscator doesn't actually have the ability to jump, right? Because there's no way to do
Right.
it. So what it does is it intentionally causes a segvy after setting the error handler to wherever it wants to jump to. So so yeah, you basically so we got to do what signal? I think the command is yeah. So no, it's not signal. Is it just segme? Pretty sure the command here I want to signal. So I use GDB a lot, but my GDB is definitely not super. Uh, there we go. It's handle. I don't see it. All right, so we need to basically not stop running the code on Segby, which is the most counterintuitive thing you'll ever experience in your life. Now we can run it, and it will at least run. You can see when we run, we actually have what, like a couple dozen segmentation faults, and then some uh, illegal instructions. So I think let me remember how I did this here. Break puts. No. Aha. Okay. So I set a breakpoint on printf, so we're printing access denied now. So we're gonna string stack. This is gonna be disgusting.
Yeah.
Actually, not that bad. I think that might be it. That seem right?
Yeah, I think so. Although it might be reversed. You can see
It's
the file
reversed.
got
Yeah,
reversed
for
there.
sure it's
Yeah.
reversed. Yeah, for sure it's reversed. So yeah, and that's pretty much what I did is like, dude, I'm gonna set breakpoints like everywhere I can set breakpoints and hope that I just get lucky. And obviously in this case I did, right? So I have the advantage of basically a ton of experience with C, right? Which leads me to the ability to like, okay, well, how are we comparing strings here? Uh, boom. Right, so I didn't even have to mess with demufuscating this, but like as I guess as our little final thing here while I'm drinking this smoky scotch because I need it discussing this. So, do we want to talk for a minute about the one you did for CTF, the mufuscated
Sure.
one? So you definitely didn't. So I've seen the source code, obviously, and I think I was probably the closest to actually solving it. I was off by one
Yeah.
character.
So that one, the solution, it didn't take just a single answer. There's multiple answers that would have solved it because it actually was basically a regex, uh,
Yeah,
implemented regex inside of a C, which in this case it was doing a case, character by character, and then just doing a check. So yeah, you were
yeah.
really close, and I think there was a if I remember the regex, there was one character like in the middle that was optional,
Yeah.
and something about the way you had it, like it matched that optional. It was basically any character. So you had the whole string, but there was like a space somewhere in the middle where you needed just any other
Yeah.
character, and it would have worked.
So what I ran into and the problem I ran into was I could recover. So how I ended up doing it, getting as far as I did. Let me do this. I'll just open it over here and then try going over. So yeah, where I ran into and where I got stuck was I could recover what the actual commands were, right? Or what you were calling because I used demufuscator, right? And so demufuscator actually built this. And so this was the calling tree of your program, right? This is how it was stepping through.
Right.
And the other thing that Mufuscator spit out, so let me actually pop that into GDB there because we can look at my command history. Uh, So what I had found is one of the things Mufuscator spits out is Mufuscated binaries on the back end create memory registers because they don't have registers. So they build their own registers at given memory addresses. So basically, what I ended up doing was setting watch points on those registers. And so I was watching right every time one of those registers changed. So basically, I could see you doing comparisons on the characters, so I knew what the characters needed to be, but that character that could be anything, I had no way to recover the state table, right? Because did you use RE to C, like regex to C on it, I presume?
No, I just went through and just wrote a bunch of cases.
Okay,
Yeah,
you built a state
yeah.
table. I had no way to recover the state table, right?
Do,
So
do you have the?
I was close. Given another day, I probably would have gotten
Let's see.
it.
Do you have the source code for that?
Let's see.
Let me see. I think I got that one.
Somewhere? I mean, yes, I have the source code spit out of, right. So actually, okay, so you can see those registers here, right? So you can actually see that that's what it's doing. Here are these registers, like R2, R3, R4. There were some functions and there were some D registers, but the R1, R2, R3, R4, actually in particular R3 was the one that I kept seeing the answer in. Yeah, I don't. Do I have the? You sent it to me. Where did you send it to me? Was that on
Yeah, I
Discord?
know it was on Slack. I think I've
Yeah.
got it.
Well, you're paid Slack, so I should be able to get it out of Slack.
Yeah.
No, no. Yeah, that Slack probably hasn't had enough stuff. I have on the laptop I'm running Slack on. I don't have my LastPass logged in, so I gotta go ahead and type that password.
Yeah, if you want, I can take over. I've got the
Yeah,
source code
you got it.
source code pulled up here.
Okay.
All right, so yeah, this is the actual source, and yeah, you can see we're doing a switch case, and we're going through character by character. So the first character is Q, then we move to state one. Otherwise, we break and it fails, and then we move on to, the next case if it's U. Then we're checking to see if this was part of the regex. So the U, it could be one U or an infinite number of U's. So if you typed another U, it would just continue going back to case 2 over and over and over again. But if your next character was C, then it moved on to the next state. Let's see. Then we did R, K,
It had to be a
Y,
1.
F.
It had to be 1, yeah, because it was It was a play on Porky Falcon, because that was like the bad guy.
Yeah. So that in that CTF we had a bad guy who was called the Quirky Falcon, and in the scenario, Quirky Falcon had hacked into network. That we actually had a botnet set up, and you had to infiltrate his botnet. This is where it was. So after the F, it was looking for a Y, but it needed something else in between that.
Yeah. Yeah, so that was where I broke, is that I couldn't identify, right? I knew that state 16 was bad and I failed, right? But I couldn't because I could see that was in one of the registers, that state number was, right? So I knew if I got to 16 I had it wrong, but I couldn't tell why I had it wrong, because the code to basically do that is just absolutely disgusting, right? So
Yeah,
I have it.
It is a mess.
I don't know if you can go back to me for a second.
Yeah, let me switch back. There we go.
Yeah, so this is basically what the source code of this looks like that comes out of Ghidra. So yeah, trying to recover the state table from this. Another day, I think I would have gotten it. But I probably have 6 hours into this challenge. So kudos to you.
Yeah.
If you added anti-debug to this, I'm pretty sure it'd be unsolvable.
I actually tried to compile this one with wait, did I do Mufuscator for this one? Or
this one was Mufuscated.
Okay, yeah, this one did. Yeah, it was the other one that I couldn't use Mufuscate on. Mufuscate is very specific in the C standards that it requires. And while my code worked, it had to call the one of the Linux headers like cpoid.h, and that didn't work with the with Obfuscator, so it wasn't able to compile. But yeah, this one I definitely definitely did compile that with Obfuscator and added a lot of those state table was.
Yeah, I'm looking at this code and I'm having like nightmares. I was up till like 4 a.m. that day just going through it, and
That makes me so happy.
And by the end of that 4 a.m., somewhere around here, there's probably my handwritten notes where I've written down Corky Falcon, I've written down all the characters, and I'm like, why? And then I just don't understand why it's not working.
Yeah, I remember at some point you sent me a message and like, I think this is it. And I'm like, oh, you're so close. You just had one character you had to add in the middle there, and it would have worked. You were literally off by one character.
But yeah, it's fun. I mean, this is, I mean, great skills, right? It's like, again, my reverse engineering skills come from a combination of old BBS door games and then reverse engineering Pokemon Go for a while, right? So a little bit of ARM assembly. And then the CTFs have like really rekindled. I love doing this stuff. It's very fun.
Great. Cool. All right. So I think that does it for today. Is that all we've got? I think that was all.
Yeah. I mean, the only other one I've got is another. There's one more that we didn't go through, and it's nothing special.
Yeah. Sounds good. All right. Well, thank you, Jason, for helping us out today and going through those. Most of those I wrote them, but I hadn't actually gone through and cracked them all myself. So. You saved me some work, which I always appreciate, letting somebody else do the work for me.
Yeah, cool. Well, cheers.
All right. So so I think that that pretty much does it for the Crackmes for today. So thank you everybody for watching. Just a couple of things coming up. So we had another CTF this week, and actually this one Ross really did all the work for us. So Ross was on 2 weeks ago. He's helped me for most of the CTFs that we've done at Perch, really all of them, but the very first one, I think we had one at PerchyCon, which was just 100% done inside of Perchybana. So Perchybana is the Perch instance of Cabana. So I did that one myself at PerchyCon back in January, but all the rest of them, Ross has definitely added some of the real evil genius challenges. He's really he has a lot more experience involved in CTFs than I have as far as competing in them. I've done a lot more of planning and implementing, and he's done more of competing than I have. And he had some really difficult challenges. We walked through the B-Sides Houston a couple weeks ago, so you kind of saw what he did there. He put one together this week for it was IT Nation Secure. So Perch hosted another CTF for IT Nation Secure that went on this week, and our winner from that, Garrett, he is going to join us next week, and we're going to do a walkthrough. So we're going to look at Perchybana, so you guys can kind of see what that is and see how we found data in that, and then see some more evil genius from Ross and the things that he's done. So that should be pretty exciting to see how that's done. And then I believe the week after that, Taylor, I think you're watching, so that's going to be the 31st. So on Halloween, if you're still up for it, Taylor's got some more Crackmes. He's been playing with some Crackmes. He hasn't, I think he had one at, he worked with Tris, who's another analyst at Perch. So Taylor is our SOC director, and he worked with Tris, and they put together a Crackme for B-Sides Houston. But the one coming, or what we've got coming up in a couple weeks, these are just some stuff that Taylor's working on now. I haven't seen them yet. So Taylor, I hope I know you're watching, so I hope you've got those completed. I'll get those up on my site. So that's bamctf.com. There's a Crackme section. I'll be adding those, so you guys will get a chance to take a look at those and take a crack at those before we do the walkthrough. And then we'll do that walkthrough in 2 weeks. So that's next week. It's the IT Nation Secure. 2 weeks after that, we've got some more Crackmes. If you guys have anything that, any suggestions, any things that you want us to go over in future episodes, hit me up on Twitter. That's at BAMCTF. That's BAMCTF. I've also been uploading these after the fact to YouTube, so you can leave a comment on YouTube or on Twitch under the About section. There's a suggestion box, so you can leave suggestions there as well. Don't forget to, follow me on Twitter for any updates. Keep checking out the website, BAM CTF, for links for everything that I've mentioned above, plus all the files that we've done for challenges and walkthroughs that we've done on here, as well as other tutorials. So another video I did a couple weeks ago was related to that zero login vulnerability that was recently released. So I looked at it from an analyst perspective and looked at the emerging threat signature and what do you look at that? What do you actually look for? How can you tell if this was actually the zero login hack, if someone was trying to use that vulnerability, or if it's a false positive, because we see a lot of false positives from that signature. So the PCAPs that I use for that are also on the bamctf.com. All the Crackmes we looked at today, and then the future Crackmes will be there as well. And then stay posted for news. I showed this last week, but there's a hack to win video game that I'm working on. So I'm going to keep working on that. I don't expect that to be finished till mid next year. So this is going to take me a while to put together, but I'll probably post some periodic updates for that as well. So I think that's everything. Jason, thanks again. I don't know if you have any final words you wanna say.
No. I mean, you mentioned the Perchibano ones, right? If anyone here is a user of Perch, like if you want to learn how to use that tool, just do one of these CTFs, because it's seriously the best way you can figure out all the like idiosyncrasies of how you guys have Kibana configured.
Yeah, it's been a huge win for us. Yeah, teaching people how to use Perch, and even maybe getting some new customers, maybe even some new employees. So if anybody is interested in a job, check out perchsecurity.com and look there for, we are, trying to fill out our SOC a bit more and hire some new analysts. So if anybody's interested, let us know. And, I think that's it. So thanks again. We'll see you next time. And don't forget, if you ever get stuck, to, try harder, don't panic, and always RTFM. So thanks again.
Cheers.